Now we're going to go to question number 5, and here they ask a question about those deletion maps that help you to understand the order of the genes. And this one looks very complicated, but it's actually very easy. So the first thing that they gave you is this information. So let's put it in yellow. They tell us that there's those recessive genes that they have, and they gave you this. So there are 1, 2, 3, 4, 5, and 6 genes. Yeah, and all of them are closely linked in a chromosome. So they are all very close there in one section of a chromosome, but we don't know what is the order. Okay, so how we solve that problem? So we make 3 deletions, uh, and those deletions help us to uncover recessive alleles, as in a previous exercise that we already solved. And these are the deletions. So they give us, here there is 1, here there is 2, and finally here there is 3. And the question that they ask us is, what is the order of the genes? And suggests experiments that carry out to complete the ordering. Okay, so this question looks very difficult, but it's actually pretty easy. Okay, again, there are so many ways to solve these questions, and depending on the complexity of those questions, you can do it in different ways. In this case, this one is it can be solved in a very easy way. So to solve this question, I just want to remind you a little bit of information of before. So if you remember this idea of using deletion maps to find the order of the genes, that is like similar to these games. Yeah, and if you remember, I told you that it's very important to know how many genes are shared and how many genes are not shared, so you can start finding out which one are in the extremes, and there are different ways to represent them. Yeah, so here, for example, some in some textbook they make a line and said, this deletion goes from A to D or from B. Yeah, cover all these 3 genes, while the other deletion goes from B to C. Yeah, so this type of information, we're going to use it again, but now instead of giving us 2 deletions, they are going to give us 3, and we don't have to organize 4 genes, but we have to organize 6 genes. That although it looks challenging, is still very easy. So let's go and try to again play this game, but now do it with 3 deletions. So first thing, again, I try to, just for clarity, make these tables. So in some textbooks, they make these tables. In some of them, uh, they make graphically. They show you this with this type of lines. I try to make it with both to make it easier. And again, depending on the textbook, some of them will have a minus for deletion, a plus for when the gene is there. They can change, so it has to be clear in your textbook what they said, or in the question that they have. Also, they use just plus, that is wild type, and they use a letter, for example Z, for in the case that there is a mutation. Okay, based on that, now that we went through all this notation again that I told you, let's see. Let's try to answer this question. And what I did here is, first I color code the 3 deletions. I made a table and I graphically show where the information that we got. So here, so for example, we have the 3 deletions, 1, 2, and 3, 1, 2, and 3. Here we have the genes, all the genes, and here they said that they uncover the gene W, X, and Z. So U they didn't uncover, V they didn't uncover in deletion, in this deletion 1. In deletion 1 they uncover the one that is W, so I add a minus. Here they uncover a deletion in the gene X, so I put a minus. Y is not there, and Z it was there. So these regions. You can see them there with a minus. And I did the same with deletion 2 and with deletion 3. Yeah, so for example, U and V are here, are negative, while the other ones are plus. And why I did that? Because it can help us to start finding the answer much easier. So for example, we can start finding where are the parts that overlap, which genes sections, which genes overlap. So here, for example, we know that 2 and 3 both have a minus in this section. So maybe there's an overlapping in that region. And here, W and X, there's an overlapping in this region. If you see here, there is no overlapping. Here is the two regions that there is overlapping. But here, there is not overlapping in the minus. Yeah. So what it says is that here, in the deletion 3, yeah, in V, there is an overlapping between B and B. So this could be a point of overlapping. And another part of overlapping is W and X. Here you see W and X with deletion 2. So they could be an overlapping in these two regions. Okay, so this could be a potential order of the genes. Okay, so now let's go and try to answer the opposite question. What are the regions that there is no overlap, that belong to only one region? So let's use again the table. So what I did here is again to keep the colors, the table, and the graph. But here I'm looking for the region that there is no overlap. So and I highlighted in yellow. So plus and plus in U in the deletion 1 and 2 means that is there. That yeah, well you cover the deletion in with a minus. Yeah, in the deletion 3. So it means that that one that one is unique of that. So here we have the U. Yeah, here in V we already know that it's in two regions, so we don't include it. W is in two regions because there is two minus. Yeah, X is in two regions, but look what happened with Y. Y is a unique section of the deletion number 2, so I put it here. Okay, now if we go to Z here, the other two, deletion 2 and 3 don't have it, but deletion 1 have it. Yeah, so you can see it here. So what we did is we start putting before the overlaps. Now we're putting the ones that are unique, and we start trying to make put together this puzzle. Okay, so now we are trying to fuse the two regions. So we're going to try to take the overlaps and the regions that do not overlap. Yeah, so we already start collecting all this information. Now we have to fuse this together. And let me show you how I did it. So here are the overlaps, and here are the sections that don't overlap. So here, the first one, it will be this U. Yeah, and then we go for the region that you have a connection. Yeah, the purple and the white here, it will be the next one. Yeah, so it will go second because it is the section that overlap between these two regions. Then it will go the Y because it is unique. Then it will go the two regions that overlap. And here we have not one, but two genes. And finally we'll go the Z. Okay, so based on this could be a potential answer. It could be these three genes. Here we don't know which is the order. Why? Because there is not enough information. So, and last one will go the Z. Another option, it could be these three first, and this can go instead of XW, it can go WX. Yeah, and but also it can go in the reverse order. Yeah, so it can go. This can could be the first one and go in the opposite direction. So it will be ZWX, YV, and U. Okay, and again, this can go, and this W and X can also go in the reverse order, so it can be X and W. Yeah, so again, this question, it was pretty easy. The key here, it was just take the regions that overlap, take the regions that don't overlap, and then they put them together. And again, there are multiple ways to solve this. This one, it was not a very complex exercise, so just with this information you can solve it. The next, to test this hypothesis, the idea, as I said before in the previous exercises, you just have to make more deletions to confirm that this is the correct order, and in particular to have deletions in this that separate this X and W, so you know which is the correct order of those ones. So to create lines in that specific region with those specific markers will be fundamental to know which one go first and which one go in the other direction, and also other relations can confirm the same data. But those ones are in particular important to know what is happening there. Okay, if you have any question, let me know. Hopefully this was clear.